This is the calculator guide for Module 11 Part 3, calculating with the normal distribution. What I'm going to do is I'm going to show you how to use normal CDF and inverse norm to calculate probabilities and find z-scores. For this video, I'm going to focus on the second part of the notes, so example 3, once we actually got into an example with calculating probability, and example 4, working backwards to find a IQ score given a probability. So the first problem, we wanted to find the probability of having an IQ below 120. We found our z-score was 1.3333 using the z-score equation. So now I'm going to show you how to use normal CDF to calculate that probability. So we want to get into our list of distributions. So if you recall from the binomial, we're going to hit second vars, and that's going to bring me into the list of all of my distributions. So for this one, we want number 2, normal CDF. I'm going to hit enter. It's going to ask you for 4 things. If you have the menu like mine, this is what you'll see. If you don't have the menu like mine, you're going to type it in exactly how I wrote it out in the notes. So our lower bound is -1 million. So remember, we want it to start calculating at -1 infinity, and I put the wrong kind of negative sign in. It's not going to like that. Your upper bound for a less than problem is the IQ score or the z-score that you found, and then your mean and your standard deviation are going to be 1. So we put that in. This is what you should see on your calculator regardless of whether you have the menus or not the menus. And I'm going to hit enter, and that's going to give me 0.90878. which rounds to 0.9088, which is what we had in the notes. So this is how you enter in a less than problem. So now the second example, we wanted to find an IQ score above 90. So I'm going to go into my distribution list again, second vars. I'm going to come down to number 2 and hit enter. So now, I'm sorry, my cat, y'all, he's being crazy. All right. The second one, we wanted to find above 90, so we found a z-score of 0.6667. So that's where we want to start calculating probability. Oh man, I did it again. I put in the wrong type of negative sign. And then we want it to stop calculating probability 1,000,000 z-scores above the mean. So we're just going to put in 1,000,000. Keep your mean and your standard deviation the same. Hit enter for paste. So now this is what you should have. Normal CDF, start calculating at -0.6667, stop calculating at 1,000,000 or basically infinity, 0, 1, enter. And here we find 0.7475. So then the last type of problem we did was between 90 and 120. So we're going to go to that same number again, so second vars, get into our distribution list. Number 2, normal CDF. So your lower bound is going to be the smaller z-score, which for our case again is -0.6667. And the upper bound is going to be the larger z-score, 1.3333. Mean is 0, standard deviation is 1. Hit paste, and then hit enter, 0.6563. So that is how you use normal CDF, where you find normal CDF to calculate probability if you're given a value for x. So now working backwards, we had to use inverse norm to find the z-score for a given probability. So the first one said find the IQ score so that the area to the left of that is 0.7019. So I'm going to go back into my list of distributions, second vars, and number 3 is inverse norm. So I'm going to hit enter on that, and it asks for 3 things. The area to the left, 0.7019, 0, and 1. I'm going to hit paste. So your calculator should look like this. You should have inverse norm 0.7019, 0, 1, regardless of which version of the graphing calculator you have. And then I'm going to go ahead and hit enter. And I get 0.52987, which rounds to 0.5299. So that's my z-score. And then we use that z-score in the equation to solve for x. So inverse norm gives you a z-score. So then we did it again with the 75th percentile. So 75% is less than or equal to what value? So number 3, inverse norm. Now I'm going to change this to 0.75. Always 0 and 1. We're never going to change those. And the reason is I always want you calculating z-scores. So paste it in. 0.6745. That's what we got for that z-score, which is good. Okay. Now the next one, we wanted to find the IQ score with an area to the right equal to 0.3214. So remember, we had to use the complement rule first because inverse norm wants the area to the left. So we're going to go into our distribution list. Number 3. Using the complement rule, we found the area to the left of our unknown IQ score was 0.6786. Come down, hit paste, and hit enter. 0.463. Oh, that should have been an 8. I apologize. I did not round properly in my notes, so that number is going to be a little bit off. So you should have 0.4638. I make mistakes sometimes. It happens. I blame my cat. He's being obnoxious tonight. And then we did the same thing again for the middle 50%, but instead of 0.6786, first we plugged in 0.25 because that was the area less than Z1. And then we just basically repeated this guy right here, 0.75, because that was the area less than Z2. So that is how you use normal CDF and inverse norm. Normal CDF you use when you've been asked to find a probability for a given value of x. Inverse norm you use when you're being asked to find the value of x given a probability. So that's it for the